In the last video, we talked about how to define links and their properties. We'll do the same thing with joints now. So the first thing you want to do is select the joint you want to edit. In this case, we'll start with the one for the front left wheel. First, you want to make sure you have the correct type of joint. So in this case, we're using rotational. So once that's done, we want to click the Select Joint Pose button to select the axis. So we can now click on whichever axis we want, which in this case will be this one. And you'll see this preview will appear showing the rotation of the axis. You notice it's going in the opposite direction of what we want. So we'll just hit this button and it'll flip around. Once we're done with that, we can just hit the check mark and come back to here. In this case, the joint is continuous and should have no limits. So we'll just make sure this checkbox here is selected so that it can rotate infinitely. Once that's done, we can now work on the joint properties. There's three values that define different parts of the joint. The first two, damping and friction, are resistances that are found in the joint and help to slow it down. The effort value is the max amount of force that a motor or other attachment can exert on the joint. Now let's do the same thing for a different joint. We'll do the linear joint that goes with this elevator here. So you notice that it has pretty much the same values as the rotational joint. Most joints have the same things, they just may have slightly different values that need to be set. So I'll first start by selecting the joint pose again by clicking this. First thing we're going to want to do is select an axis. And these axes should be the direction of motion of the robot. So in this case, we'll have this axis here. Once that's done, we now want to select the limits. The way this works is the link edge is a point on the link that will move to the furthest extent of the motion. The motion limit is the point not on the link that edge will move to. So basically the limit is defined as the distance between the edge and the limit. So in this case, for the elevator, we can put the link edge somewhere down here, like about here. We can then put the motion limit as the bottom here. You'll see this arrow will appear showing the distance that the link will move. We can then do the same thing for the top of the robot, like here, and here. You'll see one of these arrows is green and the other is red. The green arrow represents positive motion, so when a positive force is applied, it'll go up, and the red arrow represents the negative motion. Once this is done, we can now return to the other window. We can now do the same thing for a rotational joint. So we'll go to the rotational joint for the wrist, and we'll start by selecting its axis. Like the other joints, you first need to start by selecting the axis it'll rotate around. In this case, it's this axis right here. So first we want to make sure we're going in the right direction, which in this case we are because it will rotate upwards. Then we want to select the limits. So for a rotational joint, the limits are defined based on the angle of the selected objects relative to each other. So we don't have any lower motion on this one, so we're only going to select an upper limit. So first we'll select the upper edge, which will be just a flat on the thing, like say this one. And then it'll rotate up to 90 degrees, which is parallel with that. You notice that this line is in the wrong direction or on the wrong side of the axis, so we can just hit this button here to flip it around to the correct side, and that's the motion that we want. So now that we've done that, we can just return to the thing, and you'll see that the limits have now updated. Finally, we'll specify the claw joints. So like always, we'll first select the joint and select its axis. So in this case, we're doing the left claw, so we'll just select the axis it's on, which is this one. And we'll see it's rotating in the wrong direction because we want positive motion to close the claw. So we'll just flip it around. We're going to ignore these limits here because we're going to be specifying them manually in the Manage Robot window. So now we got the axis. We'll finish up with that. And now we want to specify the limits. So to do that, we'll check this box here for manual limits, and now we can edit these text boxes. So the upper limit is already done because we want the upper limit to be when it's closed. So we just need a lower limit. And in this case, we'll do -1 radians. So now this one is finished. We will then do the same thing for the rest of the joints in order to make sure all of them are specified correctly. Once all the links and joints have been set for the model, we can now move on to adding attachments. So there are currently 9 different kinds of attachments, 2 of which are actuators, a motor and a piston, and the rest are various types of sensors. To add an attachment, we simply drag and drop it on the link we want to add it to. For some attachments, like say a motor, it has to be linked to a specific joint. If there are multiple joints on the link, you have to specify which one it is using this dropdown. Most attachments will have some kind of channel, whether it's a PWM channel, an analog channel, or a digital channel. This can be set with the boxes over here. These should be the same as whatever the actual robot has, so you should have the same pinout. So for this one, we'll set a PWM channel of 1. Each attachment has various values that'll set the characteristics of that attachment. For more information on the specific of each attachment, you should look in the video description for a link to documentation. So for this motor, we're going to set a multiplier of 5, as we want the maximum force that it can output to be 5 newtons. So next, we're going to add some motors to these claws. Since we want these 2 claws to work together, we're going to set both motors to have the same PWM channel, let's say channel 4. And then a multiplier of some value, we'll say 1. Because these are on the same PWM channel, they will both receive the same signal and thus will move together, creating the appearance of a geared together joint. This is a much more stable way of doing the joints than to use the gearbox joints in Gazebo, as those can sometimes have problems. So if we want to add some sensors, we can just drag and drop them and then set the values like normal. If we want to add something like, say, a rangefinder or a camera where it actually needs a position on the robot, we can drop it down and then click on this attachment pose button. This will open a window where we can start selecting the origin and the direction for the camera. So in this case, let's pretend the camera is up here, and we get this preview showing what the camera is looking at. So we want it to look in the other direction. So we can click on a direction, we'll say look along this axis, and there we go. If we want it to look in a different direction, we could just flip it around. We can also adjust the field of view for the camera if we want it to have a wider field of view, or a smaller field of view, or whatever we feel like. You can also, instead of using this axis to specify a direction, you can set it manually using a roll, pitch, and yaw. So if we wanted to, say, have this camera looking down a bit, we can set it to be 20 degrees downward. And now it's looking downward. Once this is done, we can just hit the checkbox and return to the Manage Robot window. We would want to repeat this, adding motors and sensors to all the different joints that we need them on. So we'd have 1 on each wheel, and then 1 on the elevator, 1 on the wrist, a pot on the elevator, another quadrature encoder, and maybe some limit switches and things. Off camera, I finished defining all of the different values for all the joints and links and attachments for this robot. As you can see here, we have motors on all the different joints, we have various attachments and sensors. So now we want to export the robot. So we do is we first click on this export button, and it'll run through a series of steps to verify the model is valid for export. You'll see a bunch of yellow warnings. These are things that may cause issues when you actually run the simulation, but are not so bad that it'll break it. Like you can see, this one here is some of the components do not have a material assigned. This means that your mass values may not be accurate because there's no material assigned to them. And there's no friction in some of the joints, so they may act weird. We'll also see we have an error here. This is because I didn't set a location for the camera, so it doesn't know where to put it. Because there's an error, we won't be able to export. If we only have warnings, you'll still be able to export. So right now we need to go and fix this error. So like we did before, we'll go over to the camera and set its location. We'll just do a real quick, put it there, and have it look in this direction. That'll work for our camera. So now if we go and try to export again, we'll see that it's no longer an error. And we have no errors and only some warnings. So you can go through the different values, make sure everything's set correctly, and then hit export. Choose a save location, and once you do, it will run through a series of export steps. This may take a little bit of time on larger models, although it tends to be fairly fast. So now it's done, we can take that file and move it into Gazebo.